Okay, now for reflecting. All right, so if you want to reflect the graph, if you put a negative in front of the entire function, it's going to reflect over the x-axis, and if you put a negative in front of x, it's going to reflect over the y-axis. Now the reason why that is has to do with the rules in geometry. All right, if you were to take a point, let's say 1 comma 2, and reflect it over the x-axis, what would you do? You would negate the y-coordinate. All right, so by writing a negative in front of the function, you're negating all the y-coordinates. For example, if I had y equals the square root of x, okay, that would look like this. Would have a point at 0, 0, and a point over here at 2 comma 4. Okay. Now, if I were to take, if I were to take y equals negative the square root of x, well, now if we take if we negate this 0.00's y-coordinate, it's going to stay 0, 0. Alright, if we take this point, 2 comma negative 4, and negate the y-coordinate, it's going to be 2 comma negative 4. And if we do that for all the points, our graph's going to look like the original graph, but reflected over the x-axis. Okay, now let's look at what if we negated the x. So y equals the absolute value of negative x. Sorry, y equals the square root of negative x. Alright, well now, let's take the orange graph first, okay? So if I take the orange graph and I make a table, okay, so like x and then y equals the square root of x. If I plug in 0, square root of 0 is 0. If I plug in 1, square root of 1 is 1. If I plug in 2, if I plug in 4, square root of 4 is 2. Now if I plugged in negative 1, it would be the square root of negative 1, which is I, and it's not a real number. So like we wouldn't graph that on our real coordinate plane. Remember, the x-axis and the y-axis are real number lines. Okay? Now the opposite happens with y equals the square root of negative x. Alright? 0, the square root of 0 is still 0. So slow that point there. But if I plug in 1, I'm going to get the square root of negative 1, which is I, so there's nowhere to plug in a point here. And if I plug in any positive number, it's going to be the square root of a negative, which is not a real number. Which means I have to plug in negative numbers because that will cancel out the negative already in front of the x. So if I plug in negative 1 for x, I get positive 1 for y. Okay? If I plugged in negative 4 in for x, that would be y is equal to the square root of negative 4, double negative, the square root of 4, is a positive 2. So I have the point negative 4 comma positive 2. Alright, so by putting a negative in front of x, it's like you're taking all these points and you're negating them, and thus it's going to take your graph and reflect it over the y-axis. Alright, so long story short, negative in front of the function, which means like, alright, if it's an absolute value function, a negative there. If it's a quadratic, alright, a negative like here, okay, it's going to reflect it over the x-axis. But if you have something where it's in front of x, so like that, alright, that's going to reflect it over the y-axis, alright, or something like we just saw, like a negative in front of x with the square root, that's going to reflect the graph over the y-axis. Okay, and then the other type of transformation is sort of like a dilation if you compared something in geometry. Now in geometry, when we dilated something, we usually multiply the x and the y coordinates by a number. With algebra, if you have a number in front of the function, it's only going to multiply the y coordinates by that. So if you have a number in front of the function that's greater than 1, it's going to stretch it out or make it more narrow, alright, if that number is in front of the entire function. If it's in between 1 or 0, or 1 and negative 1, that means if it's a negative, it means you have a reflection going on. But if it's between 0 and 1, it's going to compress it, make it wider. So let me show you what I mean. Okay, so here in red I have y equals the absolute value, square root of x, and in blue I have y equals 3 times square root of x. So if we look at the red graph's points, we got 0, 0, 1, 1, 4, 2. Alright, now if we compare it to the blue graph, it's the same function except y, or the square root of x, is getting multiplied by 3. So if we take this point, 0, 0, and multiply the y-coordinate by 3, nothing changes. But if we take this point and multiply the y-coordinate by 3, alright, now it goes from 1, 1 to 1, 3. Okay, if we take this point, 2, 4 comma 2 and take the y coordinate, multiply it by 3, we get 4 comma 6. All right. Notice again how the y coordinate triples. So graphically, it's going to get stretched out vertically because the x coordinate isn't changing, but for all these points, the distance that each point is from the y coordinate, from the x-axis, triples. All right. If we look at this distance here, it now triples to get to the blue point. All right. If we look at this distance here from the red point to the x-axis, that's 2 units. Now to go from the x-axis to the blue point, it triples. All right. So that algebra is going to affect the shape of the graph by kind of stretching it vertically. And if I put like a 1/2 here instead, now all those points, the distance that they are from the x-axis gets cut in half. So it's going to get vertically compressed.